so you just have to tell me if you're miserable. All right, so let's kind of go back over some things that you've seen in Algebra 1, Algebra 2, but might have forgotten. Laws of exponents. This is how I set it up on your handout with like a table. One side we're just going to write what the rule is, the other side we'll write out an example. It might even be easiest if I did the example first. If I said like 2 squared times 2 to the third, do you guys know what that becomes? Two squared means there are 2 2's. 2 to the third means there are 3 2's. So altogether, how many 2's do we have? 5. So that's 2 to the fifth. So when that base is written both times, the big number, you add those exponents. The second one, a power to a power. That's like saying I have 2 squared. Let's do 2 to the third. 2 squared means 2 times 2. The third means I have that 3 times. So how many 2's do we have altogether? 6. So that becomes 2 to the 6th. What did you do with those exponents? Multiply. So if it's a power to a power, we multiply the exponents. Do we remember this from the past? Seen it before? Okay. The third one. Let's say I gave you 3x squared. That square tells me I have everything inside my parenthesis twice. I have 3x times 3x. So when I look at that, we ended up with 2 3's and 2 x's. So what did I really do with my exponent? Distributed both. It goes to both of them. That's true if the things in the parentheses are being multiplied together. What if I said 2 to the third divided by 2 squared? 2 to the third tells me we have 3 2's. 2 squared tells me we have 2 2's. What happens? What can you do? We can reduce 2 of those and I'm only left with 1. So what did we do with those exponents? Subtract them. I said like x divided by 3 squared. That means I have x divided by 3 2 times. So if you multiply that, you get 2 x's and 2 3's. So just like rule number 3, what are we doing with those exponents? Subtracting. Yes, so there's really 2 things we would do. First, we can distribute it to both the top and bottom. Second, if the base was the same, we would subtract those. So this could involve a combination of rules. What I really want you to notice here was that that exponent applies to both the top and the bottom of the fraction. But yes, if the bases were the same, we would then go ahead and subtract. All right, anything here that seems really crazy? You understand that? 2 more rules. What is anything to the 0 power. It's really tricky. We always want to say 0. If I said like 5 to the 0, that means I don't have any 5s I'm multiplying together. The rule is it's always a 1. It kind of goes against it. We want to say 0, or it turns into the number 0, but when you're working problems, that actually changes the whole problem. So if you don't have any of them left, it's just a 1. And what does a negative exponent do? If I said like 2 to the negative 3, how do I write that without a negative exponent? Do you remember? Move it to the bottom. So negative exponents go down to the denominator and become a positive exponent once you do that. All right, so those are the general rules we have with exponents. The other things that we'll talk about are polynomials. These are just words you're going to hear me say, so we need to refresh what they mean. If I, before I get to those though, I want to try a couple examples. I didn't type these up, but I think if you flip your paper over, you have some blank space. I want you to just take a couple minutes and see if you can try a few of these. Get through as many as you can. See if you can write down the answer, and we'll check them in a second. Let's just kind of talk about them. On A, what would you do with those exponents? M. So it's just m to the 14th power. On B, also, I should have said this before, if you need a calculator, you can grab one at any time. You don't have to ask permission. So when you come in each day, or if you need one at some point, you're welcome to grab them. When we're multiplying, we're going to multiply these coefficients together. So negative 5 times 6 times negative 3. So negative 5 times 6 is negative 30. Negative 30 times negative 3. And then with my r's, we would do what with those exponents? Add them. And if there's not an exponent written, what do we assume it is? So that becomes r to the 8th. C. I have to distribute that 4th power to both. What do you do with those exponents? Add them or multiply? Multiply. So that's 2 to the 20th, which is a huge number. We'll just leave it as 2 to the 20th. And y to the 12th. All right. D. What do I have to do with my square? Distributed to all of them. What is negative 3 squared? Positive 9. It means negative 3 times negative 3, which becomes a positive 9. We would get a to the 6th power. On the bottom, this is just a b to the 1st, so it becomes b squared, and c to the 8th, because you're multiplying exponents. All right, how did we do on those? When I was walking around, it looked like we were doing pretty good. A couple little errors, but nothing big. Any questions on them? All right. Let's go over a few more terms. When I say an expression, basically your expression doesn't have an equal sign. So everything that we just did, those were algebraic expressions. Anything without an equal sign is an expression. The terms are always separated by addition and subtraction signs. So when you see a plus and minus, it breaks apart different terms. Like terms have the same variables and the same powers. So you probably remember hearing combined like terms. So when we're looking at that, we're looking at same variables, same exponents. With that, we have a few special polynomials. Monomial is anything with a single term, and I think I left a space next to that for you to write down an example. So an example of a monomial might be 3x to the 2nd y. If it's all multiplied together, it's a single term. Terms are separated by addition and subtraction, so if I don't have that, that's a term. Or if I said -6, that would be a term. It's not, there's nothing added or subtracted with it. Binomial means two terms. Can you give me an example of a binomial? If I said x minus 4. There's a subtraction sign, so it separates them. I have two terms, the x and the 4. Can you guys give me another one? Oh, come on. Somebody's brave. I don't point and laugh if you have a wrong answer. It's okay. You guys have to talk to me.
Y plus 3.
Thank you. Y plus 3. Alright, trinomial, 3 terms. You guys probably remember these from all of your factoring days. Give me a trinomial.
2x plus 3 minus 5.
I'm not sure if that's okay. Is that what you said? 2x plus 3 minus 1. That's 3 terms. If I said a squared plus 2a plus 7, 3 terms. Those are trinomials. In a polynomial, your exponents are nice. You don't have negative exponents, you don't have fractions or decimals or radicals, anything like that. Polynomial is just all whole number exponents. Anything beyond this, monomial, binomial, trinomial, we just use the word polynomial. Poly just means many. So when you have multiple terms, we just call that a polynomial. All right. Can we get through the last 3 definitions? It's really stressful, I know. Coefficient is just the number in front of a variable. So if I said like 3x squared y, what's the coefficient? The 3. Degree is the exponent. So if I said like 5x squared, what's my degree? The square. If you have more than one variable, so if I said like 5x squared y to the 3rd, degree is kind of like saying how many variables are there. In this one we have 2 x's and 3 y's, so altogether how many variables is that? 5. We have, well, 2 different letters, but total, if I have 2 of the x's and 3 of the y's, there's 5 total. So if you have more than one variable, you add those exponents together. And if we're looking at a polynomial, the degree of the polynomial is just the highest degree of any term. So I have a couple examples of that here. If I'm trying to find the degree, we look at each term, so the terms are separated by addition and subtraction. So we have 4 terms here. The degree of the first one, how many variables are there? 5. What about the second one? This one and this one. So altogether my degree would be, you just take actually the biggest. If they're added or subtracted, it's just the single biggest one. When they're multiplied, we have to put them all together, but if they're added or subtracted, it's just the biggest. So on the second one, how many terms are there? I think there's actually 3. We have 2 addition signs, so 3 terms. This is a degree of 2. How many, what's the degree of this term? And this one? 8. So overall my degree is 8. Alright. Questions? Okay, you want your first homework? It's going to be really stressful. Okay, lots of work. We have like 11 minutes, and I have, I'm actually going to do an example, and then I'll give you a couple homework problems, okay? Like, no more than 5. So I just want to do these examples to make sure we remembered how, and then we'll maybe throw a couple problems up that we'll look at tomorrow. I'd feel bad if I just gave you problems to do on your own. I hadn't done sample ones yet. Adding and subtracting, we just add them if their exponents are the same. So the 17x to the 3rd would get added with the negative 9x to the 3rd. When you add and subtract, the variable doesn't change. It's just the coefficient. So 17 plus negative 9. Yep. Alright, then we look at our x squared. So negative 10x squared and a positive 10x squared. Those cancel out. Negative 10 plus 10 is 0, so we just drop it. 1x and negative 5x. And that's your final answer. Do you guys remember adding and subtracting? Okay. What's the trick to remember if there's a subtraction? Yes. Change it to an addition and distribute that negative through. So a negative 6m to the fourth and a negative 1m to the fourth. Negative 11m squared and positive 6m squared. Positive 21, negative 35. Negative 14. Testing your mental math here. Do we need more addition and subtraction? Do you guys remember how to multiply? Let's try a couple and make sure we know. If I ask you to do x minus 3 times x plus 3, what do we have to do? So you take everything in the first times everything in the second. Remember, FOIL. What's x times x? Right, you add those exponents. What's x times 3? Negative 3 times x. And negative 3 times 3. Are we done? No. Combine like terms. So the positive and negative 3x cancel, so it's just x squared minus 9. Alright. B is probably one of the most commonly missed problems because everybody just wants to say it's 9x squared plus 4. What's wrong with that? Two of them. It means the entire parenthesis. We have 2 of them. And if we write it like that, then we see the only way to multiply these is to FOIL. 3x times 3x. 3x times 2. 2 times 3x. And 2 times 2. So combining like terms, we have 9x squared, 12x plus 4. Is it wrong if I write these in a different order? If I said like 12x plus 9x squared plus 4? No. It's not standard form. It's not how we typically see it. But with adding and subtracting, order doesn't matter. So if you flip the order around, that's okay. Alright, here's what I want to do. I'm going to put a couple problems up that I would like you guys to try. I don't care if you want to do it on your notes page or a separate sheet of paper. All I'm going to do is walk around and look that you did them. So I'm just going to walk around and kind of check your answers. We'll see if we get through all of these. I just want you to work. We might start class tomorrow with a few minutes to finish them up.